up where we left off in lesson 5-6 yesterday. In your class, we were almost through example 1, but not quite there, right? And so we had found angle C using our formula that had C squared and cosine C. We were working on B here, correct? Okay, and I don't know how much you guys wrote down before you gave up on me, but we were working on B, and so we had used the B formula, and we were trying to find angle B. So we had filled in sides A, B, and C, right? We had added 121 and the 42.25 and gotten the 163.25. In an effort to get B by itself, we had subtracted the 163.25 over to the left. And this is probably where if you didn't give up before now, you had given up by this point. So negative 138.25 equals negative 143 cosine B. Again, to work to gain B by itself, divide by the negative 43. Now, I usually, when I see a negative divided by a negative, I automatically change it to positive. So I have cosine B equals 138.25 over 143. How do we separate B and cosine? We take the inverse. So B is the cosine inverse of that fraction and came up to be 14.8 degrees. Okay. We'll be okay. And then, at that point, we already had all three sides. We now have two of the three angles. What's always your rule to finding the final angle? Subtract from 180.
That's way easier.
Okay? And I'll be honest, folks. If you use law of cosines to find angle A here, it wouldn't work. Okay? I think you would get an error. I think when you would go to do the cosine inverse, you would either get an error or it would give you the acute version of the angle, and we don't need the acute version. We would need the obtuse version. One way or the other, there would be an issue, and it would not give you the right angle A. So anytime you need to get that obtuse angle using law of cosines, it's your final angle, subtract from 180. Okay? Okay, so that yesterday was our side angle side version. Now, we are ready to look at some side versions. Okay? And so we're being asked to solve triangle ABC. And we've got two different examples here. In both cases, we are given side A, side B, side C. So they are side because you're given the three sides. I don't need to draw a picture when they give me the three sides, folks. They're giving you the three sides. Okay? With that in mind, we talked about a couple of different key points yesterday. Two key points that I underlined up in that paragraph up there. What were those key points we talked about?
One small angle.
Okay.
And remember the two sides of the triangle must add to be larger than the third.
Okay. So when you're finding angles, you always find the smallest angle first. Last time we had two angles to find, we had to find the smallest angle first. We've got three angles to find here. You must find the smaller angles first. Okay? And the other point was that two sides of a triangle must add to be larger than the third. What's that mean?
There's no triangle.
There's no triangle? Why not?
Because I don't know what it adds up to, but it's definitely not more than 19.5.
Okay.
It would be 12.2.
Okay. So, in a side situation, first thing you need to do, you don't have to write it down. I mean, I'm going to in this scenario, but do a quick visual check. Do the two smaller pieces add to be more than the bigger piece? So in this case, it would be, does A plus B, is A plus B greater than C? So 7.7 plus 4.5, is that greater than 19.5? Well, I'm with Logan. I don't necessarily know what that is exactly, but it definitely doesn't add up to be more than 19, does it? Okay, so when you look at the fact that 12.2 needs to be greater than 19.5, and it's not, okay, that is a no-go there. then that tells me that this is not a possible triangle. Okay? Two sides must add to be larger than the third side. So not a triangle. In other words, if I gave you sticks, these three lengths, you could not physically form a triangle. It would be physically impossible. And I'll write the note up here. Two sides must add to be larger than third side. Okay, so that'll save you some work if you catch that. Fair enough? Okay. Let it save you some work. Okay, shall we talk about B? Another side. Solve triangle A, given that A is 9, B is 7, and C is 5. What do you first notice?
Yeah, it's going to work this time, unfortunately.
Okay, we actually have to do the work. You know, if I'm giving you two of these, well, at least one of them has to work. So in this case, the two smaller sides, 5 plus 7, does that add to be greater than 9? It does.
Unfortunately.
And again, it's not that you have to write that check down. I'm just trying to give you a reminder, like, we need to check that. I mean, you know it's not going to happen that Mrs. Sargent would give you two in a row like that. It's unlikely the book would, but you need to check. Okay, which angle would you like to find first?
Nope, here, C.
Why is he picking C? Okay, you have to find the smallest angle first. Okay, C is the smallest side, so we need the smallest angle. In all honesty, you could find C or B first because they are the two smallest angles. So they are guaranteed to be acute angles. Okay, my rule of thumb is, though, I always just go with the smallest. And so with that in mind, C is smallest. In order to find angle C, that means I'm using the equation that has angle C in it. So C squared equals A squared plus B squared minus 2AB times the cosine of angle C. That's the format we're going to fill in. So fill in what you know. 5 squared equals 9 squared plus 7 squared minus 2 times 9 times 7 times cosine of angle C that I don't know. I would encourage you not to just do it all in your head in your calculator. I would encourage you to show a little bit of work. That way if you make a mistake, I can try and give you partial credit here. Let's see, we know 5 squared is 25, 9 squared is 81, 7 squared is 49, minus 2 times 9 times 7 should be 126 cosine of C. You can go ahead and, I think most of you are ahead of me, aren't you? Which is fine. You can go ahead and add the 81 and 49 together. So 81 and 49 is 130, I think. If anyone hears me make a math mistake, let me know because I'm doing a lot of mental here. Then, in our efforts to try and get cosine C by itself, I'm going to move the 130 over. When you move the 130 over, 25 minus 130 is going to put me at negative 105 equals negative 126 cosine C. Folks, that's normal that you have two negatives at that point. In all honesty, if you don't have two negatives, you have a problem. Okay? think that it's, yeah, I'm pretty sure it's always two negatives. To get cosine C by itself, I'm going to divide the negative 126 away. So I personally write this as cosine of C is 105 divided by 126, because I know a negative divided by a negative is going to turn into a positive, so I don't usually write those negatives. You can if you want, that's fine. How are we going to actually find C? You're going to do cosine inverse of 105 over 126. And that's going to provide you angle C. What'd you guys get to one decimal place? 33.6 degrees. Make sure you round that correctly, because that will affect your next set of answers, right? Good.
We're really going to affect the answer.
Technically, it'll affect your next two answers.
How would it affect two?
Because
You're not gonna use it.
you're going to use it in the final, because you're going to use it when you subtract from 180.
Well, yeah, so it's just gonna affect your A answer, not your B answer.
It will. It will affect both of them. No?
You're not supposed to use it. You don't have to use that to find the B.
Oh, it's an angle. It's an angle.
Yeah.
Okay.
I'm like,
In my brain, it was a side. That's where my confusion was.
What?
Okay.
I'm like, how?
In my brain, it was a side. You have to use the side.
That makes
Fair enough.
sense.
You don't have to use an angle. I'm there. I'm there. Okay. What angle are you finding next?
Yeah.
Okay. We are finding B because it is the next smallest. So in order to find angle B, I'm going to use the equation that starts B squared equals A squared plus C squared minus 2AC cosine of angle B. Are you figuring out how to pick which formula you need with a little bit of practice here? Fill in what you know. 7 squared equals 9 squared plus 5 squared minus 2 times 9 times 5 times cosine of angle B. 49 equals 81 plus 25 minus 90 cosine B. I'm going to add my 81 and 25 together. I'm at 106 minus 90 cosine B. I'm going to subtract the 106 over. 49 minus 106 is negative 57 equals negative 90 cosine B. Notice again, we have negative equals a negative. So I said that's typical. Divide to get the cosine B by itself. So you're going to be doing negative 57 divided by negative 90. And again, I know a negative divided by a negative is a positive, so I just write it as 57 over 90. In order to find B, we're going to be using cosine inverse. So cosine inverse of 57 over 90 is going to find angle B. And angle B works out to be what?
50.7 degrees.
50.7 degrees. And how do we need to find the final angle? Subtract from 180. All three angles in a triangle always add up to be 180. So it's going to be angle A plus 50.7 plus 33.6 equals 180. Angle A works out to be 95.7 degrees.
And this next one's actually accurate.
Okay. Got the information you need here. Okay. You know, those are your basic examples of how to use law of cosines. I told you guys yesterday, I'm not going to hide the fact that once you get into the middle of some of these problems, you could change over and use law of sines to find some of the other parts. Okay. I'm just trying to get you guys trained in how does law of cosines work right now. So that's why I'm using those. Okay. Now, example 3, we're going to talk a little baseball. The bases on a baseball diamond are 90 feet apart, and the front edge of the pitcher's mound is 60.5 feet from the back corner of home plate. Find the distance from the center of the front edge of the pitcher's mound to the far corner of first base. Now, I can never draw a baseball diamond, even though it's just a square on its corner. I can never draw it effectively. So, that's why you get a picture here to start with.
Can you not just use
You cannot?
Silvertail?
Well,
Why not? Is it not a right triangle?
it's not a right triangle.
How so?
We'll talk about it.
What is this square?
But, okay. Let's go with what we know. The bases on a baseball diamond are 90 feet apart. So what's that mean?
All those sides are 90.
All these sides are 90. Okay. Yes?
Yeah.
Okay. Then, the front edge of the pitcher's mound. So we have a pitcher's mound. Well, okay. So keep in mind, we have all of our bases at the corner, right? My home plate is down here. Okay. Pitcher's mound in the middle-ish. Okay. That's my pitcher's mound. Okay. Now, what they tell us is the front edge of the pitcher's mound is 60.5 feet from the back corner of home plate. So what we're looking at here is that the front edge of the pitcher's mound to the back corner of home plate is 60.5 feet. Okay? The question is to find the distance from the center of the front edge of the pitcher's mound to the far corner of first base. But it's not. It's not. Okay. Now, while the pitcher's mound is centered between first and third, it is not exactly centered between home and second.
Yeah.
It is slightly closer to home. I don't know if my picture does the job or not.
But that
Okay.
shouldn't matter.
It does. Okay.
How does that change whether it's a right triangle or not? If it's not the center.
This is not a right angle. That right there is not going to be a right angle because it is slightly in front of the line
But I think
between
the
first and
distance-
third.
I think the distance to second is like 127 feet or something.
So, now, and I'm not going to say you couldn't use Pythagorean theorem in a different form and still make this problem work. Okay, because there's a way we could use Pythagorean theorem and find a different length and do a subtraction, but the point today is law of cosine.
It's just over
Okay.
127.
Now, law of cosines works with side, side, side. Well, I'm trying to find a side here, so we're not using side, side, side. And it works with side, angle, side. So somewhere here, we need to be talking about side, angle, side. Okay. We know a side of 90. We know a side of 60.5. That means they're telling me I know the angle in between. Why is that angle in between 45? Because the angle at home plate going off from first and third is going to be 90 degrees, yes? Each of the corners makes an angle of 90 degrees. This one, going from the back corner of home plate to the front of the pitcher's mound, that will split that angle in half. So we do know that that is 45 degrees. We don't know the angle at first because that line slightly angles forward or down to get to the front of the pitcher's mound. Okay? So these two angles, while this angle is going to be close to 45 at first, it's not exactly. And this angle is going to be close to 90 at the pitcher's mound, it's not exactly. So with that in mind, we have a side angle side setup. Now, if it helps, do you want to label some ABCs? Because here's the deal. You have to know which formula to pick. We know an angle and the two sides on either side of it. We're going to be trying to find the side across from it. Okay? If I label it, I'm just going to make random labels. Doesn't really matter which one you go. If I say this is A, B, C, then that means what? That means I know side B, and I know side A, and I'm trying to find side C. Fair enough?
Yeah.
If I know angle C and I'm trying to find side C, I'm using the equation that involves C. So C squared equals A squared plus B squared minus 2AB cosine of C. I'm not going to claim you had to label that triangle. I could have definitely done that without labeling a triangle, but I'm the teacher. Some of you could have. I don't guarantee all of you could have. I think some of you still need the labels. We're in the beginning stages here. Okay? Fill in and find that distance. So I'm trying to find C squared. 60.5 squared plus 90 squared minus 2 times 60.5 times 90 times cosine of 45 degrees. Like the side angle side version we did yesterday, yes? Officially, you really want to, you could plug the whole thing in the calculator right now. You guys know me, I do a little bit cleanup. Actually, I don't have the cleanup on my paper. I must have just let you guys plug it into the calculator. Okay? I'm always going to argue better is to do some cleanup along the way, but I go ahead and plug in 60.5 squared plus 90 squared minus 2 times 60.5 times 90 times cosine of 45. And I made a typo. There we go. So before you take the square root, you should get something like 4,059. If I do the square root of that number, we are at 63.7. Okay? So C squared works out to be 4,059.857153, yada, yada, yada. When you take the square root, C becomes 63.7 feet. Okay? Not necessarily what I advise, but technically I did that without doing any cleanup, right? Your calculator can do the work. So find a happy medium that makes sense for you.
Should I go into baseball practice today and tell coach that the distance from the mound to the backside of first base is 63.7 feet?
You can. Okay. Now, you guys talked about Pythagorean theorem. You threw that out at me earlier. Of this little triangle right here, I couldn't do Pythagorean theorem. Where I could do Pythagorean theorem is if I did the whole right half of the field, because first base would be your right angle. Okay, I could do that. And then what we could look at is that you could subtract well, no, that wouldn't find that one. I was thinking of finding this one. Never mind.
Know where you would go with that.
Nope, you're right. I was finding the wrong one. I mean, then you could talk the height of that triangle.
Well, you basically, you just.
No, you couldn't even do
basically,
that.
You'd have to find the distance between first, home and second, and it'd just be a lot of work.
Yeah, so never mind. Back to law of cosines is the best way to go. Okay, now, two other side formulas that go along with side angle side and side side side. So these other two formulas, they'll be on your formula page, are ways to find area of a triangle. This first one is ways to find area of a triangle given a side angle side setup. I'm actually going to the next screen. Okay, so in order to find area of a triangle given a side angle side setup, this is the same formula written three different ways, folks. The idea is it's always going to be 1/2 times side times the sine of the angle that's between them. Okay, thus the side angle side setup. So you can just label it ABC, but it's always going to be, I mean, if you think about a random triangle, if I make it ABC, then side A, side B, side C, 1/2 AB sine C. Well, that is 1/2 side A, side B, the angle between them. Or AC, 1/2 AC sine B. Side A, side C, the angle between them. Okay, so it's always the connection. Or 1/2 BC sine A, 1/2 BC sine A. So the key is you just have to be given the two sides and the angle between them. And this is an area formula. Now, our application here, I'm going to make you think. I'm not going to give you the easy version. Find the area of a regular octagon inscribed in a circle of radius 9 inches.
We just have to find one and then multiply by 8.
Okay. No, my brain was off for a moment. You're fine. Now, find the area of one what?
So basically every point on the octagon, if it were to go to the center of the octagon, would make a triangle. And you know those two lengths of the triangle would be 9. So the radius is 9.
Are you guys with this triangle I just drew here? Piece of pizza, basically, right? The idea that it's going from the center of the octagon. The idea that each of the two sides of this triangle are going to be the same as the radius. So the two sides of this triangle are each 9 inches, right? And we need to know that angle in between them. Eli?
I have a way of finding the angle of the outside. So 180 times 6 divided by 8 and then divided by 2 again.
Okay, I wasn't gonna go that far. I was just gonna.
I'm not sure. Can I say that?
Is it 67.5?
No.
Is it 45?
Yes, according to my notes.
Because, right, so if you take from points across each other, if you take them, it would make a 180 degree line, and then you can just divide that line into 4 pieces. Because there's,
I got an easier way.
there's a line, right? 180 degrees, you got 4 triangles. 180 divided by 4. 45.
How about we just go with how many degrees in a full circle?
360 divided
360.
by 8.
We're taking this 360 degree circle and we're dividing it into 8 of these little triangles, right? Because here's one. There'd be another one. Another one.
See right there. Nope, you No, you gotta go that far.
So Logan took basically half of this circle, or half of, and did it his way. I'm saying there's 8 triangles all the way around. So I'm saying that 360 divided by 8 is 45 degrees. Okay. I didn't exactly follow your use of numbers there, so I can't exactly say why it did or didn't, why it didn't exactly work. So I'd have to look, I could look at it later, but. Okay. With this in mind, we have a side angle side setup on a triangle, right? So how are we going to find the area of that one triangle?
Plug it in.
1/2 times, what are the two sides?
9 and 9.
9 and 9. Times, notice it's the sine, I know we're in law of cosine lesson, but sine of what angle?
45.
45.
We're in a 2 over 2, by the way.
Now, that's going to give me, what's this going to give me the area of?
One triangle.
One triangle. What do you have to do with this answer?
Multiply it by 8.
Multiply it by 8. Folks, let the calculator do the work for you here. Mine is listed as a whole number answer in this particular problem. What are we getting? 229. What would be my label? Inches squared, because we're talking area. Okay. Okay. That is your side angle side option of finding area of a triangle. I don't have a name for that one or anything, but it's a triangle formula that works. Area of a triangle formula that works. One more formula, yes? Okay, we're going to talk about Heron's formula. Heron's formula works in the side, side, side scenario. So Heron's formula is how we can find the area of a triangle given all 3 sides and no other information. Okay, now notice, given that ABC are lengths of sides of triangle ABC, did you catch this piece right here? S is equal to A plus B plus C divided by 2. So A, B, and C represent the sides. You've got to understand that S is something called the semi-perimeter. And in order to find the semi-perimeter, you add the 3 sides up and divide by 2. So it's half of the perimeter. Okay? Then, once you know S, in order to do the area of the triangle, you're looking at this right here. So the area is equal to the big old square root of S times S minus A times S minus B times S minus C. Okay? It's a very easy formula to use if you understand it. So, our example, find the area of a triangle with sides 13, 15, and 18. Where are 13, 15, and 18 going into your formula for? They're going to be which pieces?
ABC.
ABC. I would recommend before you get started, you find S. How are we going to find S?
Add 13 plus 15 plus 18 divided by 2.
Okay. 13 plus 15 plus 18 divided by 2. Or find the perimeter and divide it in half. 13 plus 15 plus 18 divided by 2 is?
37. 13 plus 15 plus 18 divided by 2.
Okay, make sure you do 13 plus 15 plus 18 equals and then divide by 2. You have to add those numbers first and then divide by 2. Otherwise, if you just hit 13 plus 15 plus 18 divide by 2, your calculator is just dividing 18 by 2 and then adding 13, 15, and 9. Is that what we did? I'm guessing here.
Yeah.
Okay. Now, Find your formula, folks. We're filling your formula. Area is the square root of S, which is 23, times S minus A, so 23 minus 13, times S minus B, so 23 minus 15, times S minus C, so 23 minus 18. You can go straight to the calculator, or you can do some cleanup by hand. It's going to be the square root of 23 times 10 times 8 times 5, if I'm not messing up my mental math. And at that point, I'm in for the calculator.
So we don't have a unit for this.
We do not. I have a label on here. How do you label if you don't have a unit is going to be my question.
Where units?
Yeah. So, what do you guys end up getting?
Well, I forgot to change all my 37s that I already put in for S.
So, we're not going with his answer. I know 23 times 10 times 8 times 5 ends up being 9,200. The square root of 9,200, I have a whole number answer again, is 96. And I have mine written as 96 square units. Or you could say units squared. Okay, guys. We got a few minutes to spare even. Okay. Your homework is on page 440, 2 through 28 evens, 31, and 32. Have it ready to go for tomorrow, and we will start into some chapter review, looking at a test towards the end of next week sometime.
For the octagon one, did you truly get a whole number, or did you